All right, welcome. Today we are jumping headfirst into the world of quant equity. We're going to look at how some really powerful machine learning techniques are being used to try and get an edge in the market.
And really, it all boils down to this one fascinating question. How can a machine actually learn from its own mistakes to get progressively smarter and hopefully better at picking stocks? It's a pretty cool idea, so let's get right into it.
So here's our game plan. We'll start with a big picture concept, which is ensemble learning. Then we'll zoom in on a specific power tool called gradient boosting. We'll talk about why it's so useful, see how it's actually applied, and then, of course, we'll look at the results to answer the big question. Does it even work? Okay, so let's kick things off with that first piece of the puzzle, ensemble learning. What exactly is it, and why is it such a big deal when you're trying to make sense of something as messy and unpredictable as the stock market?
At its core, ensemble learning is really just the wisdom of the crowd principle applied to machines. Instead of betting everything on one super complex genius model, you build a whole team of simpler models. They're often called weak learners. The big idea is that by combining all their predictions, you get a final answer that's way more accurate and reliable than any single one of them could be on its own.
And this really gets to the heart of the difference. Think about it. A single genius model might be right most of the time, but if it has a flaw, if it's fundamentally wrong about something, well, the whole thing can just fall apart. It's brittle. The team approach, on the other hand, is all about being robust. A few of the simple models might be off, but their errors tend to cancel each other out, and the collective decision ends up being much, much stronger. Okay, so if ensemble learning is the general strategy, how do we actually do it? Well, that brings us to a really powerful technique called gradient boosting. This is where things get interesting. The best way to think about this is like a student studying for a test. First, a simple model takes a shot at the answers. It gets some right, some wrong. Then, in step 2, we figure out exactly where it went wrong. We calculate the errors. Now, here's the clever part. We build a new model, but its only job is to predict the mistakes of the first one. It's like a specialist that only studies the questions the first student failed. Then you add that specialist's insights to the original student's answers. And you just keep repeating this process. Each new model that joins the team is laser-focused on the remaining errors, making the overall prediction stronger and stronger with every single pass. So you might be thinking, okay, that's a neat process, but why this? Out of all the machine learning tools out there, why are boosted trees such a good fit for something as chaotic as financial markets?
Well, it turns out there are some huge advantages. For one, financial data is full of these weird, complex relationships that aren't just straight lines on a graph. Boosted trees are amazing at finding those patterns. They also don't care if your data is messy. You don't have to perfectly clean and format everything. Critically, they have safeguards built right in to prevent overfitting. That classic trap where a model just memorizes the past and becomes useless for predicting the future. Plus, they're fast, and they can tell you why they made a certain prediction.
And that last point, it's an absolute game changer. One of the biggest knocks on machine learning in finance is that it can feel like a black box. You put data in, an answer comes out, but you have no idea why. That's a non-starter for most portfolio managers. But boosted trees give you something called feature importance. They literally tell you which data points, like a stock's book yield or its price momentum, were the most important for making the final decision. It peels back the curtain.
Okay, so that's the theory. Enough talk, right? How does a quant fund actually take this tool and use it to build a real portfolio of stocks? Let's check out the playbook.
So here's a look under the hood of a real model. The universe is just US stocks. The goal here isn't to predict an exact price, but something much more practical. What is the probability that this stock will do better than other stocks in its own sector this month? So the label is simple. 1 for outperform, 0 for underperform. And to make that prediction, the model gets fed a ton of data, over 200 different features covering everything from valuation and profitability to momentum and risk. Which, of course, brings us to the moment of truth, the question that really matters. After all that sophisticated work, did it actually perform any better than the old school methods? Well, the numbers speak for themselves. This table covers a 15-year period. Just look at that far right column for the gradient boosting model. The annualized return came in at 14.3%. That's better than both a traditional model and a simple blend. The return per unit of risk was also the highest. But check out that bottom row, the information coefficient. You can think of the IC like a model's batting average. 0 is pure guesswork. The machine learning model's score is nearly double the others. That is a huge leap in predictive skill. This chart makes it even clearer. What we're seeing here is the performance of the stocks the models liked the most, the top 10%, versus the ones they liked the least, the bottom 10%. And look at the ML model's bars. It delivered the highest returns for its top picks and the lowest returns for its bottom picks. That spread between the best and the worst is what you're looking for. It shows the model is just plain better at separating the future winners from the losers. And if you want to boil it all down to one number, here it is. The machine learning portfolio, on average, outperformed a simple blended strategy by 3.1% per year. In the world of quant investing, that is a massive difference. So this all kind of leaves us with one final thought. We've seen that these models get powerful by obsessively focusing on their own mistakes, learning from them, and getting better. So if that's the key to success for a machine, what could we as human investors learn from taking that same exact approach?
And that's all we've got for this one. If you found this useful, do us a favor and help us make more by liking, sharing, and subscribing. Thanks so much for tuning in, and we'll see you next time.